Good afternoon, everyone. So this is a little bit something else, not paleontology, but it comes from a paleontologist, which is a bit unusual. And I decided to nominate this site, and you will see later why. But it is one of those places that is really well known worldwide. And it's the Tsumeb ore deposit, and you might only know it as the Tsumeb mine or Tsumeb minerals. My site is called Tsumeb ore deposit of Namibia, site number 075. And it is one of the richest ore deposits with respect to variety, rarity, and aesthetics of minerals in the world. So where is it located? It is in actually northeastern, not northwestern Namibia, in a small town, a mining town called Tsumeb. So Namibia is on the southern tip of Africa. So it's part of southern Africa. And if we look at the geological context, you have this ore deposit located within the limestones and dolomites of Neoproterozoic Otavi group, which is the blues, all the blues that you see there. Yeah, okay, here. And this is essentially what this ore deposit looks like, and I will explain it a little bit better in a few seconds. So when we look at this ore deposit, you can look at it from a longitudinal section or from a cross section. You are dealing with a 120 by 15 meters in cross section, going all the way down to 1,700 meters. So that's quite a large and a long pipe. And the upper part is, as I said, it is within the upper part of the Neoproterozoic Otavi group, which are really old rocks in Namibia. But the age of the ore deposit itself is much younger, 530 million years plus minus 11 million years. The inside of the ore pipe is infilled with feldspar breccias and feldspar-rich sandstones and sandstone breccias of the overlying Malden group. And how did these minerals develop in these feldspars or in these sandstones and sandstone breccias is through hydrothermal processes that were fueled by karstification processes within this northern part of Namibia. So what we are dealing with is a polymetallic ore deposit, a copper, lead, arsenic, zinc, silver, germanium, molybdenum deposit with 3 oxidization zones. So you have 3 oxidization zones, which are not well shown in this diagram, but one is here, and one is a little bit lower down. So these images are probably some of the things that you've seen before. Some of the nice minerals, I tried to really choose some spectacular ones for this presentation. So the first thing is that we are dealing with really a huge variety of minerals, of lead, copper, molybdenum, cadmium, cobalt, and the list goes all the way to gold and mercury. Then we also have extensive secondary mineral development of things like tsumebite, schneiderhönite. So you can see some of these minerals have funny sounding names because they are named after well-known people, mineralogists. And it hosts about 489 minerals in total, 72 of which were first described from the Tsumeb ore deposit, and 25 minerals which are just only known from this Tsumeb deposit. So the scientific tradition is an interesting one because it starts off with not being a scientific tradition, but just missionaries first reporting on copper ore that they discovered in northern Namibia in 1857. And you know, we've got a huge missionary history in Namibia with Finnish and German missionaries coming to Namibia. And then from there, we start having people who are interested in mining coming to Namibia looking for resources. And in 1892, you had Matthew Rogers, who first examined the copper ore of the Tsumeb ore pipe. It was then further explored by Christopher James in 1908, and finally the first scientific publication or research started in around 1906 and still continues today. It is one of those exhaustively studied ore deposits, and especially the minerals, because people just love these minerals. They are absolutely beautiful. They range, as I said earlier, in different habits, different colors, and so forth. So here, just to also indicate something that could be of interest to you, is the indigenous people of the area already knew about the copper ore of Tsumeb. So the San people, by some known as the Bushmen, had basically taken it upon themselves to have this as a reserve that they traded with the local Ovambo tribe. And the Ovambo tribe were clever enough that they, again, had another secret. So even though they didn't know where the copper ore came from, they knew how to smelt it and produce all sorts of useful implements, which they then, again, traded back for copper ore. So here you have some pictures. This is a cocoa pan, which is from the Tsumeb mine, which is located at our museum, just to show the public how mining was done in those years, and some beautiful old photos, some of the first copper ingots that were produced, and pictures of the Devet shaft, which is also well known. And of course, the challenges that came with mining were things like underground water, and that area is extremely rich in underground water. In fact, there are a lot of underground caves that are filled with water, and we've also got Lake Oshikoto nearby, which in the beginning was one of the main sources of water for the mining staff that started off the mines. We continue with a scientific tradition. So we have, in 1906, we got Otto Schneider of the Berlin Mining Academy, who detected the first type mineral, which he called Ottaviite. And then we've got Hans Schneiderhöhn, who developed some really good methods for ore identification, and he really took some different microscopes and developed his own ore microscope. This is his original ore microscope, which can be seen in the Tsumeb Museum. And from there, there were a variety of other individuals, obviously mineralogists and also metallurgists. Hugo Strunz from the Berlin Institute of Technology, Bruno Geyer and Gerhard Söhnge from Tsumeb Corporation Limited, that was the company's name that at one stage mined the ore pipe. They all described very rare minerals like stotite and zöhngeite and other minerals. And here you can already see zöhngeite, named after one of the people who really worked a lot on minerals from Tsumeb, called Söhnge, Gerhard Söhnge. So what are the main arguments for having nominated this particular site? The Tsumeb polymetallic site contains one of the most diverse examples of mineralogical paragenesis observed within a single mineral deposit. We have unique hydrothermal processes providing oxidizing waters to lower parts of the ore deposit, causing the formation of a variety of minerals with increasing depth of the ore body. So this is also just a paragenesis diagram showing the different minerals that you can find depending on where in the ore body you are located. So obviously different minerals, in order for them to form, you need different types of conditions and different brines for them to form. To continue with the main arguments, this provided special conditions, as I said earlier, for the development of secondary minerals as well, of extreme beauty with respect to form and habit, and the detection and occurrence of extremely rare elements in the deposit like germanium and gallium led to the development of extremely rare minerals. And these are just a few pictures of some of the mineral specimens of Tsumeb that I have in the museum. And most people, visitors to the museum, when they see this mineral, they can't believe that that's actually a mineral. They think it's something that I've made in the laboratory, some, fiberglass or something like this, or plastic material. So this still attracts a lot of attention, and I've managed, together with some collaborators, to identify within old collections that were donated to our museum in 1996, to identify several new, not previously known microminerals for the Tsumeb ore body that we then were able to publish. And with that, I would like to say muchas gracias, dankeschön, thank you for your attention.
Thank you so much.